So Andy's book discusses a little on key aspects of climate policies, and I'm not going to go into the details other than to point out that before IPCC and so on used to use this kind of a framework, what was then referred to as an integrated framework, where we had climate change with warming, sea level rise, precipitation change, droughts, floods, extremes, and so on. And adaptation was not a word that was used by IPCC for a long time, because in the first several assessments, because that would mean that we are giving up on mitigation or reducing our impact on climate change, on climate, and just think of how to deal with the changes that are happening. Finally, the whole framework came around to consider adaptation as an inevitable part of dealing with climate change, especially for developing countries, which were not historically responsible for the increase in greenhouse gases. So now it is included with impacts on human and natural systems like flood and water resources, ecosystem and biodiversity, human settlements, and human health are the impacts or outcomes of climate change to which society has to adapt. And the adaptation and socioeconomic development paths were considered interacting with each other. So in that sense, the socioeconomic development paths of economic growth, technology, population, and governance could not be dealt with, or policies couldn't be made for them without worrying about impacts on human and natural systems of every policy, just like every technology we develop and implement, population growth and so on. And as I've mentioned before, population growth remains kind of controversial in terms of who consumes the most, and whether reducing population or people who have fewer kids are actually consuming less. That's not the case, as all the data indicates. And then mitigation, of course, is where we are focusing on emissions and concentrations, so greenhouse gases and aerosols and all the activities that produce them are to be mitigated so that we can reduce our impact on climate change. Now that was taken then to look at these things, various adaptation and mitigation measures, and those that fit both into adaptation and mitigation. There are many such schematics, you can call them. This one is from Center for Cleaner Policy, CCAP. So here the adaptation and mitigation synergies are being looked at. So if you just consider adaptation, of course, afforestation, open space preservation, land use change, relocation, infrastructure protection, building design, flood mitigation, emergency response, business continuity plans, and community engagement. Community engagements are included. Sorry, it's a bit fuzzy, the figure, I expanded it too much, but you can go here and find it. Under mitigation alone, we had things like energy efficiency, renewable energy, combined heat and power, which we talked about, CHP, which is a way to increase the efficiency of heating and energy production. Sustainable transportation, methane capture and use, industrial process improvements, and carbon sinks. And you have things which are good both as adaptation and mitigation, like green infrastructure, which reduce energy use and increase energy efficiency, and also are protection against extreme events, disasters, building codes for dealing with droughts, floods, heat waves, hurricanes, etc. Power system resilience, so including new grids. Protect sustainable transportation, water and energy conservation, needed for adaptation as well as mitigation. And building weatherization, where you are dealing with either increasing temperatures or increasing extreme events and storm surge, flood, inundation, and so on, right? So I think you get the idea. What is now clear is that if we look at the emission trajectory we are on, basically on business as usual despite the long negotiations for more than 2 decades. And the global warming targets we are looking at, like 2 degrees C with a 67% probability by 2100, or 1.5, which is much more ambitious, then it's obvious that some sort of geoengineering will be tried, will become essential. People like David Keith from Harvard are pushing very hard for solar radiation management, or SRM, like aerosol injection in the stratosphere, as we will see in a minute. So the earlier holistic framework or integrated framework of only mitigation and adaptation now pretty much has to include some form of geoengineering, and in fact the National Academies of Sciences in the US has put out a report on ocean carbon dioxide removal, what is called ocean CDR, carbon dioxide removal, I think. So here again we are focused on reducing mitigation under reducing emissions under mitigation, and in adaptation we plan for impacts, building resiliency and improving response capacity, like the Sendai framework for disaster management. Under geoengineering, of course, we are going to introduce additional global changes to counteract emissions, like reducing incoming energy or direct air capture, or other ways of drawing down carbon, which we will see in a minute. We have seen that before as well in Roger Schmittner's group, but it's always good to repeat some of these points. And this article from Physics Today also makes points about the need for knowledge-based expansion, like scientific assessments, including IPCC and other regional assessments, technology developments to meet the impacts and adaptation mitigation requirements, including geoengineering, for, let's say, food, water, energy, and health, and observations needed to do these things to close adaptation gaps, emission gaps, and to track impacts of geoengineering. And research, of course, to understand the consequences of what we do. So this is from Encyclopedia Britannica, which is almost comprehensive, but this has to constantly be upgraded as new ideas are being proposed. So sulfur aerosols from volcanoes, balloons, and aircrafts, these have provided metaphors for how spraying aerosols into the stratosphere can reduce incoming energy. Pros and cons exist. We know that volcanic eruptions also cause widespread droughts, the crop damages, and of course the idea of reducing solar radiation and not reducing CO2 can be counterproductive, because if you keep increasing CO2 while reducing solar radiation, you are still going on with things like acidification and acid rain and so on. Plus, as soon as you stop the solar radiation management, the warming is going to take off again. So I have a full course on geoengineering that you can look up. There are more exotic ideas like wrapping glaciers in high albedo material. Protecting critical glaciers on Antarctica and Greenland may lead to some sort of experimentation on these things. Tree planting and forest expansion is, of course, what are called natural-based solutions, carbon capture. High albedo roads and rooftops, already some are being attempted. Artificial trees, already Gary Lackner, I think, is designed some, but they are too big, so scaling is going on. Scrubbing towers already being deployed in some places. Industrial scrubbers already exist, so direct air capture methods. There are genetic engineering of deep-rooted crops to deal with carbon capture, so carbon capture and storage, solar reflectance, so SR and CC. Biochar production is another way to put away more carbon, so you grow vegetation, paralyze them and put it on the soil. Increased soil carbon enhances nutrient carbon soil structure, nutrient retention, soil moisture persistence, drought resilience, groundwater recharge, and so on. Genetic engineering of reflective crops increases surface albedo, so that's a solar reflectance idea. will be tried for sure. Liquefied CO2 transferred to spent oil reservoirs. So a lot of the CO2 captured is now being used for what is called enhanced oil recovery EOR, but this is about sequestering on geological timescales. So pumping station transfer CO2 to the ground and deep ocean. So these are being tried, will be tried more for sure. Whitened Clouds, Australia is trying it around the Great Barrier Reef. It's to reduce, increase the albedo and reduce solar energy coming into the system. Orbital mirrors and sunshades could be less Frankensteinish than these aerosols, one has to see. So dissolved salts from seawater sprayed to change cloud optical properties. So these are the misting vessels, again already going to be tried. This is ion fertilization of the marine environment, where there is ion limitation. It can spur algae growth and export carbon. And there was long debate for a decade about whether this will work or not, but now it is again considered as a viable option. This doesn't include things like enhanced alkalinity, so ocean alkalinity enhancement experiments are going to be tried, including enhanced weathering, so ground up rocks to be spread on land, so as CO2 is increasing and carbonic acid, which naturally does the weathering on geologic timescales, can be accelerated, but the life cycle analysis to see whether the energy involved in grinding up rocks and transporting them, etc., will result in net CO2 uptake or not. But mineral dissolution products will run into the ocean. There is already additional CO2. So mineral dissolution products to be shipped into the ocean to enhance alkalinity, which continues the buffering reactions of the ocean that we talked about. So CO2 plus H2O goes to bicarbonate and carbonate, and to keep this going, alkalinity needs to be maintained, so pH needs to be regulated as well. So you have ground up rocks weathering, giving you alkalinity, including silicate and trace metals. So there is CO2 compensation through ingassing, as this. Basically, you don't want the ocean to get saturated with CO2. As CO2 increases very rapidly, these reactions cannot proceed, and as we saw before, carbonate ions end up getting used, which reduces calcium carbonate supersaturation, which makes acidification and negative impacts on corals and other shell-forming animals. So alkalinity enhancement basically is to keep the ocean from being a sink and continue to take up CO2, even additional CO2. Okay, so this is a bit of a repetition of what we already said, but in the context of Andy Dessler's book, I wanted to say this before we move on to again re-emphasizing some of the points about top-down and bottom-up or market-based approaches to reducing emissions. So carbon tax, cap and trade, and other market mechanisms to see how mitigation can be incentivized. Okay, so we'll look at that in the next podcast, and then move to introduction to climate modeling. Okay, so let's leave this here for now.